Hello.
Hey, what up? What up?
Hey, how are you, Stanley?
Good, good. How are you? Saw you
Good.
got a new hair color,
Yeah, and you used to also have all the interesting hair colors.
but now I'm changing back to black. So it's new. It's new. Still new.
Okay. Yeah.
All right.
Anyway, today is actually the last Dev Space live stream for the year. So we are really ending off with a bang.
Yeah.
Yeah, super
Merry
excited.
Christmas.
Yeah, can't wait for Christmas break. Yeah, I think the chat is super lively already. We have like Sue in and a lot of
Ambrose.
Ambrose. Yeah. So yeah, welcome to Developer Space channel and thanks for tuning in today. I'm Jiaxing from the Google Developers Relations team, and Stanley is one of the organizers for Go Singapore. We hope everyone is keeping safe and well wherever you are. Do leave a comment in the live chat and let us know where you're tuning in from, whether it's from Singapore or outside of Singapore. I think today's speakers are both from outside of Singapore, so they are really excited to hear their thoughts as well. And before we begin, let me briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups from around the region to learn, connect, engage, and be inspired. As part of the developer relations team, we aim to empower and connect the community with our people, programs, network, and technologies. And for today's session, Go Singapore is no stranger to our community. We are super excited to be hosting them once again. And today, as we mentioned earlier, it's our last live stream event in our channel this year. So without further ado, I'll hand the stage over to Stanley to share more about the awesome speakers we have today. Yep, over to you, Stanley.
Thanks, Chasing. Oh yeah, I just learned that today is Thanksgiving. So happy Thanksgiving.
Yeah.
So for our Go Singapore meetup today, we have two very exciting speakers. Ole from Ardan Labs, the same place that Bill Kennedy works. And we have Dave Appleton, who I think most of us would in Singapore would know because he has been joining a lot of conferences and events in Singapore. Yeah, so without further ado, let me let me get Ole online.
So, hi, welcome. Yeah, I want to talk about microservices and software design and why we don't talk much about software design nowadays. And yeah, welcome to my talk. Who am I next to working for the same company as Bill Kennedy does? I've got 25 years of professional software development background, almost 20 years of it in Java. So I started 97, 98 with Java. And now about 5 years with Go. And for 3 years, I'm co-organizer of the Berlin Go Meetup. And yeah, often worked as a software architect or similar. So I've seen a lot of projects and seen many problems there. In the old days, when I still was using Java, and almost everybody did, or still does, many people, it was the day of the monolith, and you had always only one system, was always one deployable unit. There was no question asked. Operations insisted on this. They wouldn't know what to do with multiple deployables. And it was never a question. Even the developers liked it. And yeah, system grew without bounds, was complete spaghetti code often, and was neat for the developers because they didn't have much overhead to introduce something new, didn't need to set up anything, no Docker, no whatever. They just hacked in a little code somewhere and it worked. And yeah, the downside is all this spaghetti code, of course. And yeah, usually becoming a big ball of mud. And this is something what it looks like. So you have something nice on the outside, some utility things that are quite independent, something quite structured, even here in the middle. This can make sense out of it, but here it's complete chaos and you have no chance to understand how this works. And this is quite typical. Another example would be this. Still, you can find something on the outside, but the middle is even worse, and you even need colors to distinguish anything at all. And yeah, quite complex thing. And software design is really the thing that tries to keep this mess at bay. And Wikipedia says it's all activity involved in conceptualizing, framing, implementing, commissioning, and ultimately modifying complex systems. I think this is a bit broad because it includes all of architecture too. So the definition that I know is that it's everything of that within one executable, within one system, within one deployable unit. And everything between deployables, between executables was architecture level, like what database to use and how to connect to it. This was architecture level, and design was the thing within the own self-made executable. How did you structure the software, right? What packages you use, what classes, and so on. And this is has been quite a reputable discipline because it was for monoliths. This is really important, of course, but we all know it has largely failed, and so people have been looking for a different solution nowadays. Right? And it has been done in Java usually, and Java is quite bad because it allows circular software dependencies between classes, but ESPO between packages. And this is the huge thing, really, that is quite awful. This makes bigger software systems really hard to understand. And yeah, it doesn't completely prevent dependencies between projects. I think, yeah, but it's not encouraged. I never have seen this as a real problem, but the circular package dependencies are a real problem in real life. And what tools do we have for software design? So our IDEs are quite good for it already. Right? They have structural analysis, and you have all the refactoring tools for renaming classes, methods, variables, and moving things around and extracting stuff into their own methods or classes. And big companies even have their own tools, especially Google is famous for this, right? They seem to have a wonderland there. But yeah, nobody else can afford that. And so it's quite hard. Now we have microservices, right? And this is more like one system, but 1,000 deployable units, right? And yeah, nowadays, this is the DevOps and cloud native thing that insists on this. And yeah, I haven't seen this question so much. And yeah, would like a bit more discussion about it, maybe a compromise. And systems still grow, of course, without bounds. It's just that they look a bit different. And now it's becoming a spaghetti architecture instead. And let's take a look at that. So this is a service diagram from Yuba. You might recognize it from before. That's because the real class diagrams, you can't find them on the internet anymore. They are hidden, they look too ugly, and you can't recognize anything at all. And so I had to take these service diagrams, but they look very similar. Or even even worse a bit than this, because they try to convey even more information. And yeah, but it doesn't help you much. It's still a huge mess. And this is this spaghetti architecture thing. And this is from the famous Monzo blog post, how they keep 1,600 Go services running. And yeah, it's quite a great thing to achieve, but I fear when some good old developers leave the company who have all the structure in their head, it will be very difficult. And I hope they are big enough to have good tooling up until then. Let's see. And so what are the downsides of this spaghetti architecture now? So updating a dependency, 4,000 microservices, this is quite hard already, right? Some things might be simple and formal, but there are always these harder cases. You have to do things by hand, and this is not fun at all. I've done this for like 50 microservices, and this took me a couple of days already for a seemingly minor change. And moving functionality to other services is completely unsupported. I haven't seen real tools for this at all. I just know copy paste via text editor or your standard IDE, right? And yeah, this is not too great, unfortunately. Not comparable to what you can do within one code base. And cutting services in a different way is almost impossible. I think more and more people recognize now that they didn't cut the microservices the perfect way the first time, and it's getting really difficult for them to move to a different way, to use a different pattern. I've worked for a company who had that problem with some other problems too, but it was really, really bad and slowed us down a lot. So Go is quite good for software design because it has been engineered with scalability in mind on any level, really. And packages are made for encapsulating functionality, and you can't have dependency cycles between packages. But the Go compiler simply prevents this, and this is really great. And yeah, tooling for preventing more unwanted dependencies between packages is quite simple to build. And yeah, I want to show you one such tool. And oh, I just remember, if you have questions, please put them in the chat and ask them a bit before, because we have some lag. There might be half a minute or up to 1 minute until I get a question to know, and then it might be late. So please, as soon as you have some question, please ask, and I will answer them at the end. So this tool, I called it Spaghetti Cutter, right, to win the fight against spaghetti code. So I'm not fighting the spaghetti architecture because I don't know yet how to do this in a proper way. I could get rich by doing that probably, but yeah, I instead developed an open source tool that is fighting the code, spaghetti code, within one project. And it's for Go code, of course, documented, ready to use. Small command line tool, you can use it for CI, CD pipelines, and of course on your developer machines too. And it prevents spaghetti code with error messages and non-zero return code that would stop the CI pipeline usually. So it's not automatically cutting anything, right? But spaghetti preventer wouldn't be a nice name, right? And I couldn't have made such a nice photo either. So please forgive me for that. And finally, the configuration is quite good because it gives an overview of the project. It's quite nice documentation, you will see. And in the next iteration of it, I want to automatically generate documentation too. I will mention that at the end. Let's take a look. You can just start it, and without arguments, it would search for the root of the project in the current directory. Otherwise, you can give a root. And the root is found by the .spaghetticata.hjson configuration file. And yeah, we have to talk a bit about configuration. You can have simple paths. This is just a constant path. It can be nested, of course, and stars are allowed. And a star can replace anything except a slash. So you can even use this when you say, I want this package, including its test package, that you just add a star at the end, and then it matches both. This is quite simple. I use that sometimes. And double star is possible too. It's almost the same as the normal star, except that it does match a slash too. So you can have many sub-packages or whatever matched by that. This is already quite powerful. Let's see what you can do with it. I'm supporting tool packages explicitly because almost everybody needs this. And you can have multiple tool packages. This is an array. And sub-packages aren't tool packages themselves. So this is a single star, so it only matches everything after an X. So it's every sub-package of X, but not their sub-packages automatically. And the thing is that these sub-packages aren't normal packages either, because they, by being a sub-package, they naturally inherit all the restrictions that tool packages have, that they aren't allowed to import any other internal project packages, but they aren't allowed to be used by other packages either. Right? So you need explicit configuration for that. And similar for database packages that are explicitly supported. You can name them, you can have multiple things. Some people like to have their domain types in the root, and sub-packages aren't database packages automatically either. If you want all sub-packages to be database packages too, you can just use the double star here, and that's it. And finally, the tool supports God packages. These are packages that can see and use everything. And this is usually not needed, as every main package is a God package by default, right? This is the idiomatic go way, so I want to support that. And I try hard to encourage idiomatic go wherever possible. You can say that you don't want to have God packages at all. So this is rare, but if you have a large code base and then you might have several parts that are independent of each other, then you would have to use explicit configuration to configure the main packages. And finally, you can configure size. This is the maximum size for a package, and it's measured in kind of minimal lines of code. It's not that easy to explain how it's measured exactly, but it is an exact measurement, and the tool displays the measurement, so it's easy to adapt. You will see that soon. And it helps you to prevent some clever developer to just put everything into one huge package, and then the structure looks neat and small, and until you find out that some packages are way too big and completely unstructured within themselves. And you have spaghetti code within one package, right? This isn't so much better either. So I encourage rather small packages this way, because this is the way we can structure our code bases in Go, right? And now explicit configuration. You can allow additional things with this allow additionally configuration. And you can read this line with allow superdomain to additionally import domain X subdomain 1 and domain Y subdomain 2. Or super tool, so a tool package would even be allowed to import other tools or database packages or even domain packages. And stars are allowed here too, even in the keys. So this is quite powerful already. So you can override anything, and comments are allowed and encouraged here, right? This is HJSON, so human readable JSON. And please do this for documentation purposes. Right? So you can and should tell why these additional allowances are necessary and useful. And one other powerful thing is you can say, for example, that a tool package or all tool packages are allowed to have sub-packages and are allowed to access those. And right, normally they wouldn't be allowed to do this, but this way they are, and they are of course only allowed to use their own sub-packages. So without this dollar here and this $1 here, everybody, every tool package would be allowed to use any other tool sub-package, and we don't want that, of course, right? So every tool package should only be allowed to use its own sub-packages, of course, and this is a very compact way to say that. So the configuration should always be rather small and easy to read and understand, and should never grow much beyond one page or something like that. So I don't want to have the next like Kubernetes configuration or something like that. And another thing that you can do, that you restrict things and say allow only in. And this you can read as allow domain subdomain 1 only in the packages domain X and domain superdomain, right? So another thing you can do, similar to the key value match before, that you allow big domain packages to have their own database packages, for example, here. So any domain package, deeply nested, possibly can have database packages under it, and it is only the domain package is allowed to use those and not everybody. And so if you have relatively big code base and not microservices, this can be quite nice. And finally, you can use this for external packages too. This is the only thing that makes sense to be used for external packages. And you can have the external package as key and then allow only certain internal packages to use those external ones. This can be quite handy too, right? Especially when you have extra packages that wrap something or so. You can be explicit here. So what does the output look like of this tool? First of all, it tells you what the configuration looks like and the root package that it did find. So this way you can easily see that you got the right configuration file and didn't start it in the wrong directory or messed up the configuration or whatever else. And then, as promised, all the sizes of every package is shown. And finally, it would report errors and return a non-zero error code, usually 1 when it finds a problem, and 0, of course, when there's no error found. So my conclusions here are that, yeah, software design is currently a bit dead in microservice land. I've seen really small services that just did contain 50 to maybe 100 lines of real business code, and the rest around it was scaffolding, copying things around, HTTP and queue handling and so on. And yeah, but not really business logic. And you don't need a lot of software design for something like that, of course. But you pay a quite high price for it. And yeah, I would suggest reasonably sized services that are compromised, especially when you have natural boundaries for services. Then this makes a lot of sense, and don't artificially cut things into very small things that can be independent, but yeah, aren't really logically. Yeah, tools like this, Spaghetti Cutter, help quite a lot to prevent the spaghetti code problem. So it's not really a reason to cut services smaller than necessary anymore. And yeah, please enjoy your pasta and nice bites. And yeah, if you have any questions, this would be a great time now, or even a little bit before this, but let's see. You have any question?
Yeah. Thanks, Ole. Thanks for the talk. Let's see if any questions posted. Maybe not yet. Oh, okay, great. Okay, guys, if you have any questions, keep them coming. Thanks, Ole. Thanks for spending time with us. I know you are in Germany. It's a few hours behind. Yeah. Thank you. Right. Thank you. Stay around, and we will welcome the second speaker. Thank you, Ole. Right. Next, I think we have Dave. Dave is familiar in our Go circuit. Today is going to present something on blockchain as part of the toolkit. Right, Dave.
Hi. I need light. Wow. Let's have some light. Okay. We have light.
Right.
Good morning, good afternoon, good evening, depending upon where you are. Okay. Yes. So those who know me, you will know that I have fallen down a blockchain rabbit hole for the last few years, and I keep on trying to tell people they should think about blockchain. So I will try to explain it to you during this. I'm going to assume that probably most of the people here didn't attend GopherCon India, which is where I took this. Basically, I basically reworked something I did in GopherCon India a couple of years ago, but more specifically for the message today. Okay, so what I'm going to try and explain or try and convince you is that blockchain, we've all heard a lot of the hype about blockchain, and we're talking about cryptocurrencies a lot. What I'm going to try and put over is that blockchain can be a very useful part of a normal software toolkit, right? So that's me trying to explain it to you. And right down at the bottom, you see this really cute GopherCon India icon. Okay, so I've been working on the Ethereum blockchain for a while. So I want to kind of share with you a little bit about what excites me about the Ethereum blockchain, to try to get some of you to think about either working on a blockchain project or bringing blockchain into your project in very specific areas. And also to let you know that being Go developers kind of puts you in a very special place. Okay, so here we go. I'll introduce me. I will give you my 5-minute introduction to blockchain for those of you who haven't actually come across blockchain before or haven't really jumped into understanding it too much. From there, I will extend that into Ethereum and smart contracts. And we will have a little bit of a look into, or a glimpse of, the Go Ethereum code base. I shall show you very fast, don't look at it in any detail, please, it's horrible code, just how the Go Ethereum helps you develop software to interact with the blockchain in Go. And at the end, we'll go into some of the things Ethereum is used for today, which is a lot more than it was when I first wrote this early 2018. Okay, so let's get started. Me. You're in Singapore. You should know me. I lived in Singapore from 1982 to 2012, which was a long time. And after that, I just nipped over the causeway. So I'm now talking to you from Johor Bahru. I haven't been to Singapore since February, owing to the fact we have the causeway closed. But well. So I started programming in 1968 because I got into trouble a lot at school, and my teacher thought it would keep me out of trouble. It didn't. I've spent years doing instrumentation and machine vision. I sold custom designed equipment to many of the MNCs in Singapore. And then in 2014, I started work on blockchain and worked with a few companies on it. And now I'm pretty much a blockchain consultant most of the time. So, blockchain in 5 minutes. Here we go. What is a blockchain? It's a load of signed transactions put into signed blocks, which are added into a chain, in other words, a linked list, by signed links, which is distributed all over a decentralized, I'm reading this, it's terrible. It's put all over a decentralized network in a manner so that everybody on the network agrees that there's only one version of it. And they call that consensus. There, done. Yeah, except you've probably got some questions. So, what's a transaction? It's anything that can change the value, the state of something. A transfer of value or data. So, for example, from Dave to Alice, I want to send Alice some money. and send her a message with it, happy birthday. And if this was being done through a website, you could just have a link like this. You know, the parameters to it would be from Dave to Alice, amount equals 100, and so on. And assuming that you start with a blank slate, the current state of your system will be the sum of the effect of all the previous transactions. Right? So obviously I couldn't send the transaction if I didn't have any money. Okay, but I didn't mention transactions, I mentioned signed transactions. So to try and demonstrate this, I'm going to go with a quote from John von Neumann, which you can read. But if we get to the next slide, I have a problem. I think my back end may not be working terribly well. Let's try it again. What I should have here, which obviously was working until I tried to demonstrate it, is an illustration that if I take that quote that you saw on the previous page, change one full stop to a comma, the number that resulted from it will change dramatically, right? And I'm doing this to try and explain because I taught, instead of transactions, we said signed transactions. So you've all come across, I'm sure, hash functions. You use hash functions to obscure passwords, for example. And the reason you use them is a small change in the data causes a large change in the output. So if you take your transaction and you hash it, the hash verifies that nobody changed the transaction. Except, of course, that if I wanted to forge the data, I would also give you an updated hash. So that doesn't help. So what we now do is we encrypt the hash value using public key encryption, which will then prove that the transaction came from me. And let's proceed. So, encryption. You create a truly random private key, right? A private key is a random number. You get a public key and then an address which you derive from the private key. If I encrypt the data and I give you both the data and the encrypted data, you can derive from that my address, which is public information. Therefore, you know that I signed the transaction. So now I would send, do it from Dave to Alice, 100, message, and then I add a signature to it, which is the encrypted hash of the rest of the message. And you can have a look at this. And from this and this together, you can derive the fact that it really did come from me. And I produced this really crazy picture of it, which is partially accurate. There are all kinds of things you can do with this. So I encrypt it to give me a signature. I can decrypt it with my public key and get the hash back, and I can compare it, or I can recover from the data and the signature my address. Right? So the signature is a proof that the data is authentic, that it has not been modified. Right, so now we have a load of signed transactions, and we stick them into blocks. Now, a block is very simply like one page of a ledger. It is a whole load of signed transactions accumulated together in order. There is a sequence to them, just like there is on a ledger. So you have a link to the previous block, and you put a signature for the block at the end. So now, with the link to the previous block, everybody knows that this follows on from there. And with this block signature, therefore, you are guaranteeing that the whole thing is unchanged, it's invalid. Sorry, that it is valid, idiot. Okay, and you do this in a manner that everyone's agreed, and I am not going to go into much of the details on this, except because there are different ways of doing it, but the design of the consensus algorithm should insist that no collusion of people can affect the state of the blockchain, that everybody agrees on everything except for maybe the most recent history, and whatever hasn't been agreed on will get agreed on very fast, right? So that we can we can guarantee that everything over 15 minutes ago will never ever get changed, because it would take someone too much work to fake it and get everybody else to agree. Now, what that would mean is that you and I, if we both have nodes, we have an identical copy of the state of the blockchain. There. And for Ethereum, you can have a look at Etherscan, which will show you that it has a whole load of blocks, and it shows you the latest transactions. You can see a list of all the transactions in a particular block. Etherscan is effectively the Google of the Ethereum blockchain. Right, and that's it. That's my blockchain in 5 minutes. I'm sure it didn't take me 5 minutes. It took me a bit longer. It always takes me longer because time is an illusion. Okay, so now what makes Ethereum special? Because I'm sure the moment blockchain is mentioned, the first thing that comes to everybody's mind is Bitcoin. And Bitcoin operates pretty much exactly as I have explained so far. It has like a coin which you can transfer. You can send 1 Bitcoin, you can send half a Bitcoin, you can send a 1,000th of a Bitcoin if you want. But that is all Bitcoin does. It transfers Bitcoin from one address to another. Ethereum is slightly different because Ethereum was founded on a novel principle, which are smart contracts. So, do you remember the data field in that transaction? Right? I mean, I'm sure you remember I was incredibly generous. I sent Alice $100 or 100 somethings, hopefully not rupiah. But I also had a message. I said, happy birthday, buy yourself something nice. Now that's a load of bytes. So let's get into this. No, let's go back to there. Sorry. Okay, so we got the data field, and the data field can be interpreted. The first attempts to do anything was just to hook those bytes of data and interpret them as instructions to do something. But Ethereum went beyond that. Ethereum took the concept of not only can we just send information with one transaction, sometimes you can take this information and you can hang it on the blockchain. Right? So I could take my code and I could leave it there for other people to interact with. Right? Now, in order to do this, we need a way to give my blocks of bytecode an address. So I send my transaction in a specific way. I've got a horrible feeling I explained this a bit later on, but I always get ahead of myself. We have compilers that create bytecodes. We have virtual machines. So at the heart of Ethereum, you have a virtual machine built into the Ethereum client, which will interpret those bytecodes. It will take some of that bytecode and leave it there as transactions. And sometimes it will take that bytecode and treat it as an interaction with a contract. And this is running on thousands of nodes across the ecosystem. And I will try and catch up with that in a moment. Right? So a smart contract, it is a load of data hung on a particular address. You send your data in a specific format, right? So we start off obviously with a source code, which is something vaguely like JavaScript or vaguely like Python. There are two major languages. There's one called Viper, which is obviously the Python-like language. And there is Solidity, which is a JavaScript-like language. Right? You compile that code into a bytecode, and if you take that bytecode, you can then deploy that and you get back an address. Right? So your contract ends up on the blockchain and it can be interacted with it. And you can interact with that contract because that contract now has an address. You can send a transaction. Instead of me sending it to Alice, I can send it to an address on the blockchain. And if you look at this carefully, it tells you, it says up here, okay, there is a function name, swap exact ETH 4 tokens, and that has parameters. And from the 0x down to the end here, that is the bytes that I sent. The first 4 bytes operate the function routing. So that determines that I'm actually going to call this function. And everything else in here are the parameters encoded in such a way that the contract I'm talking to will not only execute that function, but it will do it with this data. Right. Now, this is me talking to the blockchain. Now, when I talk to the blockchain, I have to push my transaction onto the blockchain, and it has to get included into a block and agreed by everybody else, and that can take some time. Reading back from the contract can happen a lot faster. And the first way is to call a read-only function. Okay. If I call a read-only function in the contract, I do not need to interact with the entirety of the blockchain. I only have to interact with my local node, the one point with which I'm connecting to the blockchain, which could be a Raspberry Pi sitting on my desk. Right? So I can interact with there, and I can find out what the state of the contract is. The other way would be that when my transaction has been completed, the contract itself can log data, and so it uses events and it puts data back into the log, which ends up inside the transaction when it has been mined. And Ethereum uses something called Bloom filters that will allow you to do very fast searches for events that have been emitted by a contract. So we can read back so we can push data to a contract, we can make things happen, we can get information back. So why is this important? Well, a lot of things are now happening with blockchain. Blockchain is starting to move into the enterprise, and it's moving. One of the places it's moving is basically in making people more accountable. Because one of the principal advantages of the blockchain is that it is immutable and it is transparent. So you can see every transaction. Now, when I talk to my bank, I log into their back end. I have to assume not only do they remember everything that I did. So if I log in and do a transaction, I have to assume that they are not only going to keep that information properly, but also that every single transaction is being executed correctly. There is no way that I can check. Or I can check in a black box format. I can do what I did in the early 90s. I can look at my bank statement. I can see my housing loan, the interest they're taking for my housing loan. And if it doesn't seem to add up to me, I can then do what I did in the 90s. I went to Hong Kong Shanghai Bank and I said, you are calculating my housing loan wrongly. And that is a really painful thing. It took them months to actually agree. I mean, the bank manager couldn't calculate housing loan interest. It was scary. But it took them months to agree that their calculations were wrong. I mean, finally they did, but it was a very uphill thing. If more information is transparent, you can see how everything is working. But even if you have proprietary systems, we've got my ERP system talking to your ERP system. If something goes wrong in the interface between my system and your system, we then have a problem figuring out whose system has got a problem. Did you send the transaction? Did you not send the transaction? Did I fail to acknowledge something I had received? Or did I not actually receive it? So, this thing about making sure that these things work properly can be a little bit of a problem. And if you have a trusted third party, how can you make sure your trusted third party is indeed trustable? So one of the benefits that your blockchain can bring is that we can have, if I look at what I drew, we can have two proprietary systems talking through middleware to a smart contract, right? I would have my keys operating my side talking to the blockchain. You'd have your keys, and we can have a backwards and forwards conversation where particular items of that conversation are being logged. And once we do that, you cannot dispute the things which have been logged by this. So now we have a record which is transparent, it's permanent. There are options using enterprise blockchains like Quorum, which is effectively Ethereum with a few privacy steroids. But the information that would be logged by the contract could actually be used as some kind of point of truth or point of evidence in terms of any disputes. Okay, so yay, there we go. This is, I mean, there's a lot more to using blockchain. We know, for example, that JP Morgan are now using blockchain as an international settlement layer for them talking to other banks. We know, for example, that there are several things out there in the real world for tracking artworks and other valuable items. on the blockchain. We know that UPS, for example, trialed using blockchain for tracking and managing their delivery services. So there are a lot of people out there using or investigating where they can use blockchain. So let's see what happens now for Go. As Go programmers, because we are a Go meetup, and those who know me know that Go is one of my preferred languages. So the most important thing is that the reference implementation of the Ethereum client is written in Go. Not only is it written in Go, it is incredibly well written. Right? There's a very nice guy, Peter Suragi, in Romania, who is basically leading the project, and he and the other developers have done a fantastic job, not only to build a client, but to, if you are writing in Go, you can link right into the code base to do a lot of the things you need to do. So it's very easy to code transactions, and it results in a framework that would allow you to build code to interact with the blockchain very easily. And I have been using this now for the last 4 years to do all kinds of things. Right? And sorry, yeah, just there. So yes, it's Ethereum / Go Ethereum on GitHub. Right? Not only is it written in Go, it is so amazingly well written. It is. In 2014, I had to work on a different code base. It was called Ripple. It was written in C++. And I seriously could not find my way around that code base. It was absolutely horrible. The moment I saw the Go Ethereum code base, it was like reading poetry compared to the Ripple code base. Okay. So yes, it is really nice. It is being well maintained all the time. Now, I'm sure you can't read this too well, and to be honest, we're not doing a deep dive, so I don't expect you to try and read too much of this. But there are a whole load of tools to allow you to play with writing smart contracts, to prototype smart contracts. These tools are all evolving. Sadly, a lot of them rely upon JavaScript and Node, which breaks my heart. But I build my own in Go, so I'm happy. But this contract is kind of like JavaScript, but it's got blockchain specific things in here. So, like I said, if the de facto client is written in Go, you can interact with the logs in a very low way. And one of the things that has been created is ABI Gen. ABI is the application binary interface. ABI Gen will put a wrapper around your contract. So if you want to read through the logs, it's very simple. You can create a while loop. You create an object that will just read the events, and you just create a while loop reading the events as they come in. Or you can create a stream to read those events. So you can read past events. This is pretty much what would be involved, just to read through every single event in the past. And I had to use something like this to analyze when a particular token had a problem and I had to migrate it to a new token. So I just pulled out all the past events off the blockchain. Oh, by the way, if you have questions, please post your questions, and we can come to them towards the end. Right. You can read the contact status equally easily. Right. It just becomes a function call using the wrapper. And you can send transactions equally easily. Right. All you need to do is you have your private key. You need to make sure that that private key has enough funds to pay for the transactions, which is not much. And you know, everything is, you know, I mean, like this amount of code is enough to interact with a contract. Now for testing, you know, I did mention most of the tools are written in JavaScript, but thank heavens the people who built the Go client also built a simulated blockchain so that you can test out your contracts by deploying them on your simulated blockchain, and you can basically hammer these with basically the same kind of thing, test-driven development. And there is one project, Chainlink. They build oracles. They're also hiring Go programmers, and their entire test suite is all written in Go. Right. So the great thing about the simulated backend is you know that everything's going to be handled correctly because it uses exactly the same Ethereum virtual machine that the Go Ethereum client does. Okay, so there is definitely a niche for Go programmers in the Ethereum space. That's my first take. So if you're a Go programmer and you're looking for a new opportunity, that you can, for example, check out Crypto Jobs List, and you will find people like Chainlink are hiring Go programmers, and most people in the blockchain space are working remote. If you are incredibly good at blockchain, of course there are other blockchains out there also hiring Go programmers. As a Go programmer, you will have a tool set that will put you in a slightly different place from the other programmers. There are a lot of people jumping into writing smart contracts. Right? When I started writing smart contracts in 2015, 2016, you know, there weren't very many of us, and that was a good opportunity. But pretty soon, obviously, where there's a good opportunity, a lot of people follow. And now there are a lot of people writing smart contracts, but there are not so many people writing Go code to interact with the blockchain. Right? So yes, you will have a tool set which is unmatched by the main group of programmers. And you will find it incredibly interesting. Also, however, if you are still building enterprise software, it is worth looking at using Ethereum smart contracts for particular places where you need public records, where you need traceability, where you need accountability in operations between two people. Right. I think that was kind of it. Right. Let me see. I have some questions here. Let's look at the questions. Proof of work is horrible. Yes, proof of work is horrible. Proof of work, the method by which the Ethereum blockchain works is by lots of people doing an awful lot of work, wasting a lot of energy, and that is used to kind of be your stake in making sure that nobody can hack the blockchain, take it over. If Ethereum 2 which is a proof of stake blockchain, which does not waste as much energy, is launching on the 1st of December. And it's going to be a very careful introduction, because this is the ultimate in testing in production. So they're actually going to be there's actually going to be a migration from the current Ethereum blockchain to Ethereum 2 over the next few years, to try and get more off of proof of work. Okay, what else do we have? Benefits of blockchain outweighs mainstream methods. The answer to that is I don't know. And this is why I say that, you see, when it comes to writing software, I'm very pragmatic. I use the best thing for the best, whatever seems appropriate at the time. There are times, as I say, there are times when blockchain can be very useful. There are also thousands of times when using blockchain would be a really bad idea. People said, over the American election, people were saying it should be on the blockchain. Then you couldn't argue about false results. But there again, if you talk to the best researchers in the business, they say using blockchain is a really bad idea for a whole load of reasons that they can give you. So no, I wouldn't. So it's really a matter of horses for courses. It's just like, when would you use Postgres versus MongoDB? Well, you use what seems right at the time. It's a matter of building your design. In terms of maintenance is concerned, hey, the great thing is you don't have to maintain the Ethereum network, right? You don't have to have a server on all the time if you've got things on the Ethereum code base. You don't have anything in the cloud at all, right? My ERP system running on a machine in my office can talk to your ERP system sitting on a machine in your office. All you're paying is the transaction cost to put your transaction on the blockchain. But there's a lot of trade-offs, and you're going to have to do your own research on this. I'm just putting ideas in your head, right? Which is one of my bad habits. If you want to read logs in a blockchain that's several thousand blocks deep, how do you go to that particular block efficiently? The answer is you don't. It's very unlikely that you want to see all of the logs in one block. If you were to do that, yeah, you go to Etherscan and they basically index the blockchain, stick it in a database for fast dicing and searching in different ways. But what you normally want to do is you want to see what a particular contract has done. Now, if you want to do that, you'll you'll basically filter the logs, and that uses the Bloom filters, so that the Bloom filter is it can give false positives, it will not give false negatives. So if you're looking for a particular kind of log, you can go through block by block. You don't have to look at the individual transactions. In the block, there is a Bloom filter which will tell you whether it is worth looking in that block to try to find the transactions. Right? So basically that there's an index for logs associated with the blockchain. Right? And you literally just ask your client, you say, filter the logs, find me transactions for a particular contract, this type of transaction, possibly this kind of transaction with these index parameters, right? And all of that is indexed in the Bloom filters. And if you want to be faster, you can give it a starting block. So obviously, if it's a contract that's only been on the chain for the last 6 months, you'd start 6 months ago. You wouldn't trawl through the entire blockchain. Yes, Ambrose, Go Ethereum is fantastic code. Really. And I have I have about 10 lines of code in there. Nothing critical, but I have 10 lines of code in there. That is like one of my little ha moments, right? Proof of work is not a bug, it's a feature. Well, it has its advantages and it has its disadvantages. But the biggest problem with it is the fact that it uses so much power, and also it slows down the blockchain. Right? Okay, now we've probably got a lot of people who are thinking, what the hell am we talking about? Proof of work. Everything in terms of building the blockchain is based on incentives. So in proof of work, you have a lot of people competing to produce the next work, the next block. So I want to send out a transaction. I throw it out into the transaction pool. I publish it to the transaction pool. And people who are called miners are now trying to build up the next block. In order that it's not just the person with the fastest computer can create the next block, there's a little contest built in, which goes like this. You build a block, and that block has to pass certain mathematical tests. And you can again, it's all based on hashing. So basically, your block hash has to meet certain criteria. And the block hash will depend on the order of the transactions, which transactions are in there, and so on. And the person who wins that, the person who meets those criteria first, gets to append the next block. And then people will take the existing chain with that block and try and add another block, and so on. And in the end, the longest chains win out, because if I will produce one with another block, and that becomes a contender. Someone else may do it at the same time, or not necessarily quite the same time, because of course things are everyone's everywhere, right? So by the time one contender will be a few blocks longer than the other one, that contender wins, because everybody will say, hey, this is the longest one, we'll go with this, right? So proof of work puts in the delays because it's not just pure computing power, it's also kind of a chance, depending upon how I put my blocks together, whether I can get there first, right? So proof of work gives the kind of randomness so that it's not just one person in control of the blockchain. The downside of it is that meeting the criteria is difficult. It has to be difficult to kind of level the playing field. Difficult mathematically, which means there are computers out there with massive GPUs, all trying to win that prize. And because they've all got massive GPUs, they're burning up a hell of a lot of power. And so we're trying to, by moving away from proof of work, you are trying to reduce the amount of power being burnt. All right, I'm looking at the last one. If you implement in production, how do you send the information efficiently to your data warehouse to use? So what you would do, if you look at it, basically look at Etherscan. Etherscan, as I said, it reads the blockchain events as they come in, but it stores them in a database. Okay? The important thing is that you should be able to verify everything. So you got a data warehouse. Do what you always do. Bring the information off the blockchain, chuck it into your data warehouse, and analyze it from there. But by having the transaction hashes, you can always go back to the blockchain and verify that everything in the data warehouse is correct. Right? So for the drill down, at the lowest level of the drill down, you can get back to looking at the blockchain. Okay, do we have any other questions on this?
All right. Thank you, Dave. It appears that was the last question. And welcome back, Ole.
Yeah, thank you.
Okay. All right. Thank you for the talk, Dave. Very informative. Yes. Okay. Exciting times Ethereum too. Okay. Okay. We've come to the end of this session. Thank you very much for the two speakers for spending time with us this evening. And this will be the last for the year for GoSG. We will come back again in January, and I hope to see both of you come back for another talk. Okay.
Thank
Thank you very
you.
much. Right.
Thank you.
Guys. Till we see you again in January 2021. Have a safe, festive season. Thank you all.
Thank you, everybody.
Good night. Bye-bye.
Bye.
Bye.